Welcome to Faculty of Technology, University of Colombo.
A place where innovation with excellence and technology transform our future. Founded in 2017, the Faculty of Technology has grown into a premier institution for technological research and education. With state-of-the-art infrastructure and a diverse community of scholars and innovators, we are committed to pushing the boundaries of the knowledge. The Department of Agricultural Technology leads a research in sustainable agriculture, focusing on biofertilizers, nanofertilizers, and advanced food processing techniques. Students and researchers develop innovative solutions to address agricultural challenges and ensure food security. The department's work encompasses enhanced crop production through modern biotechnological approaches, developing efficient and improved green farming practices, post-harvest food processing and preservation technologies, and creating value-added health foods. Additionally, it focuses on developing new farming and industry machinery, improving irrigation systems, and utilizing field-specific data-driven diagnostics with global positioning systems technology in precision agriculture, ensuring a comprehensive approach to advancing agricultural productivity and sustainability. The Department of Environmental Technology is dedicated to environmental preservation and restoration, from monitoring air, water, and soil quality to exploring biotechnological solutions for environmental challenges. Its multidisciplinary research spans diverse fields such as chemistry, biology, hydrology, microbiology, environmental sciences, environmental health, chemical industrial processing, environmental geoarchaeology, soil and water nanotechnology, agricultural soil chemistry, and geoinformatics. By integrating cutting-edge science and technology, the department drives innovation and paves the way for sustainable global ecology solutions. The Department of Instrumentation and Automation Technology is at the forefront of engineering innovation, the driving research in advanced materials, optical sensing, embedded system design, human-computer interaction, robotics and autonomous systems, industrial automation, and machine vision. With a focus on creating cutting-edge solutions, the department addresses the evolving needs of industries ranging from healthcare to manufacturing, paving the way for technological advancements that shape the future. The Department of ICT is driven technological innovation with research in human-computer interaction, human-robot interaction, data science, machine learning, cloud computing, network security, information security, and Internet of Things. Its groundbreaking AI-driven frameworks for smart agriculture and business platform and automation version in 2017. We explore technology-based society for sustainable future, followed by the learner of excellence in technology 2018 and the role of technology, health and well-being in 2019. In 2020, the Attention to Innovation, Road to Success highlighted the importance of transforming ideas into impactful solutions. The 2021 symposium emphasized the role of technology with interdisciplinary research, and in 2022, we focused on the role of technology in mitigating challenges in the higher education sector. In 2023, under the theme Research for Technological Advancement, ARIs brought together academics, researchers, and industry leaders. The event featured insightful keynote addresses by Professor Takashi Fujino of Saitama University, Japan, and Professor Mahesh W. Jaivira from University of Toronto. The highlight of the event was Innovative Product Showcase, where groundbreaking projects by students and researchers demonstrated practical applications for their work, leaving an indelible mark on participants.
As we move forward, AI continues to drive the innovation and shape the future of technology. We warmly invite you to join us at Annual Research Symposium 2024.
Good morning. Can you hear me? Good morning. Okay, good morning. Yeah, today 19, no? Next Monday you have an exam, right? Your fourth exam, as I remember. Yes, fourth exam. It's not only MCQ paper. I will share today I will share what is the structure of the paper. Okay, let's move into lesson now. We are late. Okay, do you know what's the meaning of precision agriculture? Previous video they explained for general knowledge. Precision agriculture කියන්නේ මොනවද? And there are a lot of new words. You can find these words. Normally, special word I found precision agriculture. What is this? Anyone? BST students? Precision agriculture. What is this? Precision agriculture means we can use satellite. That means GPS. තවත් තියෙනවා GPS and GIS. This type monitoring systems to monitor the agriculture fields like this. As example, think this is agriculture field. Now, by this GIS, GPS technologies, we can monitor nutrition levels of the soil and water requirements, and especially nutrients and water. We can manage according to the plant requirement using GIS and GPS. Okay, you can search. I can't remember every details I have learned about this. Normally, we can use satellites. Normally, in around our Earth, lot of satellites. The satellites data we can use to monitor and also the maintaining machines, water supply machines and water supply systems and nutrition supply systems and harvesting and land preparation machines. We can monitor by the data using satellites, the data given by satellites, that we called as they are novel technologies. They are your jobs actually in future. Okay, therefore you can find about new words and new technologies. This water supply, nutrient supply systems and preparation and monitoring machines we can maintain by your tablet or mobile phone using this data මේ වගේ maintain කරන්න පුළුවන්. එක drone එකක් maintain කරනවා වගේ maintain කරන්න පුළුවන් මේ machines using data given by GIS and GPS satellites. Understood? තව හොයන්න. Okay, what we discussed? What we discussed last week about mechanical energy. Mechanical energy. Mechanical energy. What's the meaning of the mechanical energy? What's the definition of the mechanical energy? The energy is stored on any object due to its position or due to its motion, right? This is the meaning of the mechanical. That's the definition of the mechanical energy. Okay, how many types of mechanical energy we discussed? What are the types? What are the types? Mechanical energy types? Mechanical energy types? Yes, potential energy and kinetic energy. Give me 1 second. Okay, now, sorry. Okay. Okay, mechanical energy. What's the meaning of the mechanical energy? The energy is stored on any object due to its motion or due to its position. Okay, due to its position, the energy stored on any object we called as position. Due to its position, the energy stored on any object we called as potential energy. Potential energy. Potential energy. Due to object motion, the energy stored on any object we called as kinetic energy due to its motion, right? Please, you have to remember these definitions and equations. Kinetic energy. The energy stored on any object due to object motion. Kinetic energy. Kinetic energy. Okay, potential energy again, 2 types. What are the types? Potential energy types? You mean to? Potential energy types? What are the potential energy types? Yes, good. Gravitational potential energy and elastic potential energy. Gravitational potential energy and elastic potential energy. Yes, good. Gravitational potential energy and elastic potential energy. Kinetic energy also 2 types again. What are the types? Linear kinetic energy and rotational kinetic energy. Linear kinetic energy and rotational kinetic energy. Okay, first, what is the meaning of gravitational potential energy? Gravitational potential energy. Definitions very important. Gravitational potential energy. Gravitational potential energy means what? The energy stored on any object, the energy stored on any object due to its position from the gravitational field. Yeah, gravitational field position gravitational potential energy that we call as gravitational potential energy. The energy is stored on any object due to the position in gravitational field. That we call as gravitational potential energy. What is the equation? Gravitational potential energy equal mgh, mass into gravitational acceleration into height. Elastic potential energy, what's the definition? Elastic potential energy, what's the definition? Elastic potential energy, the energy stored on any elastic object due to deformation, right? Due to deformation, when we apply external force, it's deformed. Due to this deformation, the stored energy we called as elastic potential energy. What is the definition? What is the equation? We have two equations, right? Two equations. Half Fen half Ke squared. Half, what is the F? Applied force. E, extension or elongation, extension. Half into K, what is the meaning of K? K, elastic coefficient or elasticity. Elasticity that we can discuss in our next lesson, elasticity lesson. E mean extension. Linear kinetic energy. What is this? Linear kinetic energy. Linear kinetic energy. The energy stored in any object, on any object due to straight movement, straight motions, straight path motions, like a vehicle, straight path motions. This is the meaning of linear kinetic energy that you already know. What is the equation? Half mv squared. Half mv squared is the equation mass into velocity squared. Mass into velocity squared. Rotational kinetic energy. Rotational kinetic energy, what is the definition? The energy stored on any object due to object rotational motion. Rotational motion, we already discussed. What is the equation? Half I omega squared. Half I omega squared. Moment of inertia multiplied by angular velocity squared. Moment of inertia multiplied by angular velocity squared. Okay, this is the last week lesson. Are we complete? Were we complete? We complete the energy conservation law that we completed, right? Abhi, energy conservation law. Yes, today we have mechanical energy conservation law. Okay, I told the amount of energy in a universe, it's a constant amount. The amount of energy in one universe, it's a constant value. The energy, the main energy source of universe, sun. The sun energy come to Earth as electromagnetic wave, EM wave, and as EM wave, as light and heat energy. Light and heat energy transferred to the earth. This heat and light energy absorbed by plants. This story I explained, right? Absorbed by plants, and in the photosynthesis process, this light energy convert into chemical energy. Yes or no? Light energy convert into chemical energy. Then this chemical energy, light energy convert into chemical energy. Then animals depend on this. Animals depend on this plant material. Then this chemical energy transferred to animals. Make you the they know. Kara. Okay, I will revise. Okay, I am revising. Chemical energy transfer to animals. This animal and plant dead parts again released to the earth. Then after millions of years, more than millions of years, they convert into fossil fuels. Then again, this fossil fuels get out and we can burn and get energy, right? For engines and machines, we can get energy for engines and machines by these fossil fuels, by purification, petrol, diesel, gases, kerosene. They all are fossil fuels, product of fossil fuels. They all are product of fossil fuels. In every process, they are burning, right? Then this fossil fuel burning, again heat energy released to the environment. It is now you can understand the energy is always transfer in they going in a circular path. They transfer in a circular path. That's why we call the amount of energy in one universe, it's a constant value. It's a constant amount, the amount of energy in a universe. Okay. Now, what is the meaning of energy conservation law that we already discussed? Energy conservation law. Energy conservation law. Energy conservation law. The energy conservation law. It is very simple theory. The energy conservation law, what is the meaning? The amount, the energy cannot be created or destroyed. That can only convert into another energy type, different energy type. That's the energy conservation law. Okay, go to page number. Don't have page numbers. Go to law of energy conservation. Law of conservation of energy. Energy cannot be created or destroyed. Energy cannot be created or destroyed. It can only convert from one energy form to other energy form. As example, think it is an electric device. Think it is a light bulb. It's a light bulb. Light bulb. This is a light bulb. And this is the cable. Then we can provide electric energy. Think 100 joules of electric energy supplied to this bulb within 1 second. Within 1 second, 100 joules applied to this bulb. Think within the same time, within same 1 second, 60 joules of light energy released to the released to the environment. 60 joules of light energy within 1 second. Within 1 second, 60 joules of light energy. Then what happened to the remain? What happened to the remain? Are they destroyed? Are they destroyed? No. They convert into another energy type. They convert into yes, the remain amount, that means 40 joules convert into heat energy or other energy type. Heat energy. Okay, that's why we call the electric or whatever energy types cannot be created or destroyed. That we can only convert into a one energy form to other energy forms. That is the energy conservation law. Simple energy conservation law. Then all there was an exam question, explain the energy conservation law. Okay, now you can explain what is the definition of energy conservation law. The energy cannot be created or destroyed, that we can convert into one energy form to other energy form. Any example you can use to explain that? Using example, you can explain. Okay, let's move into today lesson. Today, we have a very simple lesson. The mechanical energy conservation law. Mechanical energy conservation law. The mechanical energy conservation law. Okay. What is the meaning of this mechanical energy conservation law? Mechanical energy conservation law. Okay, first of all, okay, let's see directly what is the meaning of mechanical energy conservation law. Mechanical energy conservation law means in a closed system, understand, in a closed system, the total mechanical energy is a constant. Simple. The total mechanical energy is a constant. The total mechanical energy is a constant. Okay, this is the simple definition of the mechanical energy conservation law. Don't miss up that. The energy conservation law is a different theory. It is energy cannot be created or destroyed. It can only convert into one energy form to another energy type. That only can convert, cannot be create or destroy. This is an energy conservation law. This is a new theory. This is only for mechanical energy. The mechanical energy conservation law only for mechanical energy. Energy conservation law relevant to all energy types. Heat energy, light energy, electric energy, magnetic energy, all energy type. It's relevant to all energy type, but this mechanical energy conservation law only for mechanical energy. It's only specified for the mechanical energy that we last week that we discussed, potential and kinetic energy. That's the meaning of mechanical energy. Okay, what is the meaning of mechanical energy conservation law? In a closed system, the total mechanical energy is a constant. In a closed system, the total mechanical energy is a constant. Okay, can you understand any meaning? No, still you can't understand. Now we have two problems. What is the meaning of closed system? And what is the meaning of total mechanical energy? If you understood these 2 points, you can understand this concept. Okay, first, what is the meaning of closed system? අපි closed system එකක් කියන්නේ මොකක්ද? What's the meaning of the closed system? Any idea? What's the meaning of the closed system? Closed system. Remember, in mechanical energy conservation law, closed system is අපි තව closed systems ගැන ඉගෙන ගන්නවා doing in thermochemistry lesson. But chemistry definitions not relevant to physics lessons. Okay, ඒ දෙක mix කරගන්න එපා. It's not relevant. Closed system, it is physics, right? In physics, closed system is a system without any external agent effect. Okay, this is the meaning of closed system. As example, think wait, let's move into our examples in the tutor. This very simple part. Don't take it complex. Yes, behind. Yes. Wait, I will explain. Yes, they all we discussed, right? Law of energy conservation, we already discussed. Okay, this is the mechanical energy conservation law. Mechanical energy conservation law in a closed system, that means no air resistance or no any other external factor effect. Okay, that's a system. The total mechanical energy is a constant. That is a mechanical energy conservation law. Okay, let's take an example. Okay, now this person ride a bicycle through this road, this curve road, right? This road. If it is closed system, if we assume this is a force system, their air resistance and friction forces, all we have to neglect. That's the meaning. If these air resistance and friction forces of the bicycle tire and bicycle other parts, it is not a force system. දැන් එතකොට force closed system එකක් කියලා කියන්නේ ඒ මුකුත් effect වෙන්නේ නැති system එකක්. Friction force or other factors, only mechanical energy. Only mechanical energy. Understood? Vihanger? Only mechanical energy is converting, no any friction or air resistance or any other factors effect on this motion or this object. On this object. Okay, this is the meaning of the closed system. This is the meaning of closed system. Now, if we think this is a closed system, frictions or air resistance, no effect on the system. No effect on the system. And if any factor affecting, it should be uniform. හරි අපි එහෙමත් ගණන් හදනවා. ඒ කියන්නේ think uniform friction act on this object. That one also we consider as closed system. That means 5 Newton uniform friction force act on this object A to D. Now it's okay. But if there are no any air resistance, that is a closed system. That's a closed system. If it is closed system, always factors affect on the if it is closed system, the one option, no any factors, no any external factors affect on this object. The second factors, if any factor affect on this object, it is uniform. It's uniform initial point to final point, it is uniform. It should be uniform. Okay, this is a condition. That is the meaning of closed system. In calculations, we can discuss. Okay, that's the meaning of closed system. Okay, next point. What is the meaning of total mechanical energy? Total mechanical energy. What is the meaning of total mechanical energy? Remember, the total mechanical energy is the total mechanical energy, kinetic energy plus potential energy. That is very simple. The total mechanical energy that you already know, total mechanical energy means the sum value of kinetic energy and potential energy on this object, act on this object. Think at this point, at A point, think this is a A point. This trolley, think it is rest. Now it don't have kinetic energy. If it is not moving, it don't have kinetic energy. But if it's a total mechanical energy mean potential energy of this object plus kinetic energy. Potential energy of this object plus kinetic energy. That is the meaning of total mechanical energy. Now you can understand this mechanical energy conservation law. In a closed system means no any external factors affect. Think it's a isolated system. No any factors affect. In a closed system, the total mechanical energy means the sum of potential and kinetic energy. It is a constant value. This is the mechanical energy conservation law. Okay. Up to now, okay? Understood? Any doubt? Sadev? Sandit? Okay. Now, let's consider an example. Before that, please note down they are not given in the tube. In the space below mechanical energy conservation law, you can now note down what's the meaning of a closed system, what's the meaning of a total mechanical energy. Okay, complete. Complete. Okay. Now let's take an example. Okay, think this is the ground level. This is the ground level. As example, think child පොඩි ළමෙක් throw a normal tennis ball throw from ground level. අපි හිතමු මෙයාගේ height එක අපි neglect කරමු. The height of the neglecting the height of the child, the rubber ball is throwing to upward. මෙයා උඩට විසි කරනවා. හරිද? throwing to upward. Now according to the speed of the ball, it's moving to maximum height. It's going to maximum height, and again fall down to the ground. Again fall down to the ground. Okay, now think this initial point, the throwing moments. This is capital A. A mid point, it's going upward. Mid level, I think any point on this path we call it is B, capital B. The maximum height of throwing that we consider as capital C. Fall down midpoint in the floor down path, midpoint E, and ground level again capital F. Okay, now if we consider this system is a closed system, if this system is a closed system, actually closed system mean the air resistance, now only air resistance, no any friction or other factors, only air resistance. If we neglect the air resistance, air එක resistance එකක් තියෙනවා, that's true, but if we neglect this air resistance, assume no air resistance. If we think there is no any air resistance act on this ball, now what is this system? Now it is a closed system, right? It's a closed system. Now it is a closed system. Always this mechanical energy conservation law calculations doing by assuming all systems are a closed system. If it is not a closed system, we can't apply this theory. Now you know අපි කතා කරන Ohm's law එක තියෙනවා. Ohm's law, and next lesson we have Hooke's law. හරිද? ඔය ගොඩාක් laws තියෙනවා අපිට. We have a lot of laws and theorems to discuss. Bernoulli's theorem. Every theorem or laws, they all have a condition. They all have condition. They not accept, they not correct in all conditions. They have limitations. They all have limitations. Limitation mean they all have conditions. Samely, in mechanical energy conservation law, what is a condition? It's only valid for closed systems. If any other air resistance or other any factor affect on this object, the actual this mechanical energy conservation law is incorrect. Mechanical energy conservation law incorrect mean the total mechanical energy on a system is not constant. But if we assume there is no any other factors affect on this object, now we can use mechanical energy conservation law for these calculations. Okay, now this is a point A. Point A, initial point. Think the child throwing this ball v speed, the velocity of the ball v, and the mass of the ball m, the mass of the tennis ball m. Then if you got the total mechanical energy of this A point, the total mechanical energy of the A point, what is the equation? Potential energy plus kinetic energy. Potential energy plus kinetic energy. Potential energy plus kinetic energy. Okay. Potential energy, total mechanical energy mean total mechanical energy. It's potential energy plus kinetic energy. Potential energy plus kinetic energy. But in ground level, now potential energy plus kinetic energy mean potential energy plus kinetic energy. In ground levels, potential energy mean mgh half mv squared. In ground level, what is the height of the object? What is the height of the object in ground level? We have neglected the height of the child. Ekak passe balamu. Now think the child throwing the ball from ground level. Yes, the height 0. If it is height 0, now think it is 1 kilogram and 10 and height 0. Now what happened? The total potential energy cancel out. It is 0. Understood? I got this point. The total potential energy we can cancel out because it is 0. 0 will multiply karat 0. Then potential energy 0. You met? I got potential energy 0. Now we can say if it is potential energy 0 or height 0, now I can say the total mechanical at ground level, the total mechanical energy completely equal to the potential energy. Kinetic energy. Am I correct? Yes, potential energy potential energy 0. At ground level or height, at the point height is 0. At the point height is 0, the total mechanical energy completely equal to the kinetic energy. Total mechanical energy completely equal to the kinetic energy. I got Sadev? Terna Sandit? Okay, now let's see C point. The maximum point of the object. Now what happened? How it is, how it decide the maximum point at this point, at maximum point? How about the velocity of this object? Yeah, velocity key at maximum point. Now think this is an object. Make a now this is, I'm throwing into up. Now it is more into maximum and fall down. What is the velocity at maximum level? Maximum level එකේ what is the velocity? What is the maximum? Yes. Now velocity due to air resistance and other factors actually, not the air resistance, this kinetic energy I will explain later. This kinetic energy convert into potential energy. If there are no any air resistance, that is the reason. Due to this kinetic energy convert into potential energy, gradually this, when it is lifting, the kinetic energy gradually convert into potential energy, right? Potential energy, and its energy, this kinetic energy gradually decreasing due to its convert into potential energy. Okay, now at maximum level it's come to zero velocity, 0 ms minus 1. That's why it is stopping here. The velocity is 0. It's stop, it's come to rest. And what happened again, due to the potential energy and gravity field, it's again fall to ground level. So again fall down to ground level. Okay, at C point, what is the total mechanical energy? It is potential energy plus kinetic energy. The same equation. Now what is the height maximum, right? Then it has a potential energy. Now what is the velocity? 0 always. Yes, maximum height, always remember, at maximum height, the object come to rest. Yeah, rest downwind. I will explain what is the reason. You have to understand this. Now in ground level, object don't have potential energy. It has only kinetic energy. Now when it is flowing up, this kinetic energy convert into gradually into potential energy, because potential energy gradually increasing with height. I will explain. Potential energy gradually increase, and at maximum point potential energy get the maximum value and no kinetic energy. That's why it's fall down. Okay, due to gravity field. Okay, it has a maximum potential energy. And how about velocity? Don't have velocity, right? M, think 1 kilogram and velocity 0. Then what happened? The kinetic energy cancel out. We can cancel this kinetic energy because it is 0. Now can you understand, in the maximum height of the ball, the total mechanical energy equal to what? Total mechanical energy equal to the potential energy. Am I correct? No kinetic energy. Understood? Okay, now if I think about B point, Now A and C, okay. Think about B point. B point එක හිතන්න. Now it has a velocity, right? It has a velocity as well as it has a height from ground level. Some particular height. We don't know what is the height. Think h height. H height. Now it has mgh, potential energy, and as well as it has a kinetic energy because it has a velocity. Now at B point, can you understand the total mechanical energy? Total mechanical energy at B point equal to the potential energy plus kinetic energy at B point. And what do you think about D point? It is not E, D. What do you think about D point? D point, the total mechanical energy, the equivalent. What happened to the total mechanical energy? D point, හිතලා බලන්න. Emmet? Yeah, it is. No. The B and D height is not same. එහෙම හිතන්න එපා. No, I want this type answer. The total mechanical energy equal. Vihaga? Is it only potential energy or only kinetic energy or both? That's an need. Yes, both. The total mechanical energy on D points, total mechanical energy equal potential energy plus kinetic energy. Okay, now you can decide what happened to the E point. E point, the total mechanical energy equal to who? Total mechanical energy. The equal. Yes, don't have potential energy. If no potential energy, it is equal to again kinetic energy. It's equal to again kinetic energy. Okay, this is a story. In ground level, if it is height 0, don't have potential energy, the total mechanical energy completely equal to the kinetic energy. At maximum level, it don't have velocity, then total mechanical energy completely equal to the potential energy. If it is closed system, you can mark this data on this tube. Make sample in the tube. Go to this example. A point. If we think A point, it has total mechanical energy. Total mechanical energy equal to, it has a height. It has a height from ground level and initial velocity. Now it is potential energy plus kinetic energy. Potential energy plus kinetic energy. Note down. B point also same. B point, total mechanical energy equal potential energy plus kinetic energy. Potential energy plus kinetic energy. C point total mechanical energy equal potential energy, no kinetic energy, because velocity is 0. That is the maximum level. That's the maximum level. Maximum height. D point again same. E point, final point, total mechanical energy equal to kinetic energy, no potential energy. Okay, complete tubes. Point A has potential energy because this is the ground level, Jimit. E is the ground level. Height every time any object has height, it has a potential energy. Now, previous example, we got the child throwing this ball from ground level. If it is ground level, it don't have potential energy. But height it should have potential energy, right? Okay, the same example, the same thing explained here. The second example. Now, at this position, it has maximum potential energy. And if I cut this string, what happened? Slowing down, fall down. At this point, it has maximum, it get maximum kinetic energy. Actually, what happened, according to mechanical energy conservation law, this potential energy convert to kinetic energy, because total mechanical energy is a constant value. In calculations, you can understand this story. I think still you can't understand this potential energy convert into kinetic energy. What is this? Okay, actually, this is a story. Okay, what is the name of this? What is the name? Up make it a What is this? Yes, very good. That's a pendulum. Pendulum කියන්නේ ඔයාලා දැකලා තියෙනවනේ ඔරලෝසු වල තියෙන බට්ට. That is the meaning of pendulum. That's a pendulum. Okay, it's moving in this path, right? This is a maximum height. This is a maximum height, and again come to this level. It's a continuous flow, continuous motion. Continuous motion. Okay, now think this is the reference level. This is a reference. So ground level. This is a reference level. This is a reference level. It is starting from this level and going to maximum height in right side and maximum height in left side and continuous motion. Okay, now you already know at this level, how about the height? 0 height, no height. This is a reference level. If it is 0 height, it has maximum kinetic energy. The reason, the total mechanical energy full equal to the kinetic energy, no any potential energy. The total mechanical energy full completely equal to the kinetic energy, no any potential energy. But this point, high potential energy of C. What's the meaning? It has, this is a maximum height. This is a maximum height. If it is maximum height, mean how about the velocity of this point? Velocity is 0. That's why the total mechanical energy is full equal to the kinetic energy. This point also same, maximum potential energy. Maximum potential energy, both points. Maximum potential energy. Sorry, very good. Potential energy. Potential energy. Yes. Okay, that's the story.
Application of the law of conservation of energy to a simple pendulum. In our earlier session, we have learned about law of conservation of energy. Now, let us learn how law of conservation of energy is applied. Let us explain it by using a simple pendulum. Activity. Let's take a simple pendulum and suspend it from a stand. The normal position of the simple pendulum is noted as OA. Now, hold the ball of the pendulum at one extreme position B and release it. It reaches to the other extreme position C and goes on. If the ball goes from B to C and comes back to B and so on, it is called as
Oscillation.
when the ball is at extreme positions B and C, its velocity of the ball is 0. So its kinetic energy.
See, in maximum height, both velocity is 0. That's why its kinetic energy is 0, because half mv square, its kinetic energy is 0.
Ke is 0. When the ball is above normal height h, that is, when it is at extreme points, it has potential energy Pe, so its Ke is 0. But when the ball leaves the extreme position and crosses a mean position,
Yeah. Now you can understand these points, potential energy plus kinetic energy. I think understood, because it has a velocity and height, both, right?
its height h is 0. Then its Pe is also 0 and has kinetic energy. At equilibrium position, it has kinetic energy and potential energy is 0.
At this O point, don't have potential energy. Potential energy 0 because height 0. We think this is the level. Think this is the reference level. Okay. Now, but it has maximum kinetic energy at O point.
Position, it has potential energy and kinetic energy is 0. In between equilibrium and extreme position, it has both potential and kinetic energy. Other than the equilibrium and extreme positions, any point in the oscillation has total energy sum of P and K. The sum of P and K always remains constant.
Okay.
Thus,
this is the mechanical energy conservation law. The total mechanical energy of apihitamo think this is the A point. A penani. This is the A point, B point, C point, D point, E point. Okay. Now, mechanical energy conservation law mean the total mechanical energy mean potential energy plus kinetic energy. The total in a, if we think this system is closed system, in a closed system, the total mechanical energy is a constant. Total mechanical energy in, if you got this point, A point, the total mechanical energy is the kinetic energy, sorry, kinetic energy. The A point, understand, A point, total mechanical energy is the kinetic energy. Kinetic energy. If you got B point, the total mechanical energy is potential plus kinetic energy, both. C point, the total mechanical energy is the potential energy. E point also same, but D point, total mechanical energy, both potential and kinetic energy. Then according to total mechanical energy, according to mechanical energy conservation law, those all values are constant. That is the mechanical energy conservation law. If it is closed system, all this A potential energy, then mem kiwat haridha mama. A potential, A point potential energy equal to the, make තේරෙනවා නම් හරි හරිද? A point potential energy equal to the C point sorry, A point kinetic energy equal to the C point potential energy. Am I correct? A point means this is A point. A point potential energy. Sorry. A point kinetic energy. A point don't have potential energy. A point kinetic energy equal to the C point potential energy. Am I correct? Understood or not? If you couldn't understood, send me message. Okay, in calculations you can understand. I think you got some basic idea. A point kinetic energy equal to the C point potential energy. If other word, A point kinetic energy equal to the B point potential energy plus kinetic energy. Am I correct? A point kinetic energy equal to B point potential energy plus kinetic energy. Yes. Why? According to mechanical energy conservation law, all those points, the total mechanical energy is a constant. The A point total mechanical energy is kinetic energy. B point total mechanical energy, potential energy plus kinetic energy. You understood, Sadev?
From the above experiment, we can find the energy is transformed from potential energy to kinetic energy, and from kinetic energy to potential energy. But it is neither created nor destroyed. This is called as law of conservation of energy.
Okay, this is another
I have here,
practical. Okay, try to understand this. That's the actual experiment.
a pendulum, a track that weighs 15 kilograms, and I can lift it up 1 meter, which I have done. Now, that means I've done work. MGH is the work I have done, believe me. I've increased the potential energy of this object. 15 times 10 to 150 joules. If I let it fall, then that will be converted to kinetic energy. If I would let it swing from 1 meter height, and you would be there and it would hit you, you would be dead. 150 joules is enough to kill you. They use these devices called a wrecker ball. They use them to demolish buildings. You lift up a very heavy object, even heavier than this, and then you let it go, you swing it, then
Could you get this point? We can break very heavy and large building by using very small force. Yeah, I'll explain. Think it is a huge building. It's a huge building. Think it is a huge building. Now we have a pendulum like heavy material. Okay, if I apply force, think 100 Newton like small force. If I apply on this object, now it is what happened? It's moving to this direction and again come to this direction. Like pendulum. Now what happened? More than 100 Newton, huge force act on this object, act on this building. Due to this, potential energy convert into kinetic energy. The potential energy on this object at this level may allow the potential energy when it is flowing. What happened? It's convert into kinetic energy. Okay, that's a free energy source. Okay, I'll show you.
they use them to demolish buildings. You lift up a very heavy object, even heavier than this, and then you let it go, you swing it, thereby converting gravitational potential energy into kinetic energy, and that way you can demolish a building. It thereby converting gravitational potential energy into kinetic energy, and that way you can demolish a building.
Very small force applied. Okay, very slight force applied on this pendulum. Then what happened? Let's see what happened.
And it breaks the building. That's the whole idea of wrecking. So you're using then the conversion.
It's a very small force applied on this pendulum. Then what happened? It's get to maximum potential energy, and in the second term, this potential energy with this force, this potential energy, it can a force maximum potential energy with at this potential energy, and again in second term, it's convert this potential energy into kinetic energy. That's why huge velocity get this object and broken.
Of gravitational potential energy to kinetic energy.
Kinetic energy.
Now, I am such a strong believer of the conservation, the conversion of mechanical energy, that I am willing to put my life on the line. If I release that ball from a certain height, then that ball can never come back to a point where the height is any larger. If I release it from this height and it swings, then when it reaches here, it could not be higher. There is a conversion from gravitational potential energy to kinetic energy back to gravitational potential energy, and it will come to a stop. it swings back, it should not be able to reach any higher, provided that I do not.
Okay, could you understand this? Without any force, if he release this object with some certain height, without any force applied, freely released as pendulum, if it is closed system, make a demo. If it is closed system, think this is a pendulum. If it is closed system, think this is a pendulum, and I am going to this up to this level, and freely release without any force applied on this. Body force freely release. If I freely release, what happened? It's go to its maximum. If it is closed system, it's go to its maximum and again come to its original position. But it is doing in our normal environment. Now, due to this air resistance and other factors, if it is not a closed system, if it is not a closed system, always this second term, it's coming less than this level. Could you understand? If it is closed system, that is a level. It's come to this level. If it is not a closed system, air resistance and other factors affect on this object, it is coming less than this height. I
do not give this object an initial speed when I stand here. I trust the conservation of mechanical energy for 100%. I may not trust myself. I'm going to release this object, and I hope I will be able to do it at 0 speed, so that when it comes back.
Yes, maintain 0 speed, very important. Yagging a thing in a 4 second, නැති වෙන්න ඕන. Completely freely release. If not, so,
it may touch my chin, it may not crush my chin. I want you to be extremely quiet because this is no joke. If I don't succeed in giving it 0 speed, then this will be my last lecture. I will close my eyes. I don't want to see this. Please be very quiet. I almost didn't sleep all night. 3, 2, 1, 0. Physics works. I'm still alive.
Have you ever dropped a ball, watched it bounce a few times, and then eventually?
Understood? Very interesting, right? Okay, any doubt up to now you can ask. Okay, that is a mechanical energy conservation law. If you're doing this practical in a vacuum or closed system without any air resistance, but no damage. If we freely release, no damage. But අපි force එකක් දුන්න at least 1 Newton or 0.1 Newton applied on in our hand, it will be damaged. It will be very dangerous. Yeah, if it is string brake උනොත් අපි කතා කරන්නේ in the rotational motion. It's moving in a linear path, tangential direction, right? It's moving in tangential direction because it is a circular motion. Yes, it's moving in tangential direction. මේ කොහෙද දැන් මෙතනදී බ්‍රේක් වුණොත් එයා මෙහෙ තමයි. tangential direction. Okay, any other doubts? Any other doubts? Okay. Okay, again it is given here, the pendulum story. Okay, before these questions, let's practice one question. Question number 1, write down in your notebook. Okay, let's write our same example calculation. neglect the height of the child, and no air resistance in the path. Both assumptions. KE mean kinetic energy. Now you already know short forms. Initial level mean ground level. Okay, quickly write down final part. You have 5 question parts. Okay, that's all. Quickly write down the question. A child is throwing a 100-gram mass ball at 10 meters per second velocity at ground level. The ball reaches to its maximum height and fall down to the ground level. Within bracket, neglect the height of the child and no air resistance in the path. First one, calculate the kinetic energy of the ball at initial level. Initial level mean initial ground level. Calculate the maximum height of the ball is reached. Maximum height. Calculate the kinetic energy of the ball at a point 1 meter above from ground level. 1 meter above from ground level. Calculate the velocity of the ball at point mentioned previous part. Make 1 meter above point velocity. The velocity of the 1 meter above point. Fifth one, calculate the velocity of the ball falling down to the ground level. Ground level fall to a velocity. Okay, now you can start. Okay, what is the first part answer? First part. I complete writing question. Can I erase this? Can I change the page? All complete, right? Okay, I'm going to change the page. First start. First, you can draw a diagram for this type question. That's a better way to understand question. Okay, first, this is the ground level. This is the ground level. The child throwing a ball from this ground level, and it is reached to maximum height and fall down. This is a point 1 meter above from the ground level. This is a point, this is a B point, this is a C point, and this is a D point. That's all we need, right? A, B, C, D and Tamahan. They're asking about A, B, C, D points. Think the maximum height H. Maximum height H. H. Okay, first part. The question asks initial ground level at the throwing point, at the throwing stage, what is the kinetic energy? What is the kinetic energy? Kinetic energy equal half mv square. It is straight path. Then half mass 0.100 gram means 0.1 kilogram. Velocity squared 10 into 10. 5 joule. 5 joule. Second one is the most important one. What is how we can calculate the H maximum height? Any idea? Yes, mechanical energy according to mechanical energy conservation law. Mechanical energy conservation law. You know, throughout this path, what is the mechanical energy? It is a constant value. Total mechanical energy constant value. Yes, according to this law, we can say if it is a closed system, A point total mechanical energy, A point total mechanical energy equal to the C. C is the maximum point. C point total mechanical energy. Total mechanical energy. Now, what is the A point total mechanical energy? I found A point total mechanical energy, it don't have potential energy, no? Then it's only equal to kinetic energy. It is found. It is 5 joules. It was 5 joules. 5 joules equal to C point total mechanical energy. C point total mechanical energy completely equal to the potential energy, right? It is mgh. mgh. Now 5 joules equal m 0.1 10 into h. Now what happened? 0.1 into 10, it is 1. What is the height? Sandit? They told, what is the height? Fatima? Yes, it is 5 meter. H equal 5 meter. It's a random, not kinetic energy, not always equal to height. Okay, it's a random case. Okay, this is a method. Then it is 5 meter. This is the second part answer. Third one, first in third part, ask what is the kinetic energy of the object at B point, 1 meter above point from the ground level. That means B point. Yes, how to get this? How to get this? The kinetic energy at 1 meter above point. Third one, according to mechanical energy conservation law, what's the method? B point total mechanical energy equal to the any A or C, any point total mechanical energy. We already know A point total mechanical energy. Then you can equal A point total mechanical energy equal to the B point total mechanical energy. A point total mechanical energy you found it was 5 joules. 5 joules equal to B point has B point total mechanical energy, potential energy plus kinetic energy, you know, that we discussed. Potential energy plus kinetic energy. Potential energy plus kinetic energy means half mv squared plus mgh. Understood? Half mv squared plus mgh. 5 joules equal half mass 0.1 v squared we don't know plus mgh mean m 0.1 g 10 h 1 meter. H 1 meter, not now 5. We get the B point. Careful. Now you can solve this. 5 joules equal 0.2, 0.1 into 2, 0.05 v squared plus 1. Then 1 get into this direction, then it is 4 joules equals 0.05 v square. Sorry. Kinetic energy tamahane no. Yeah, my mistake. I have found the kinetic energy. मैंने यहाँ kinetic energy. Kinetic energy plus mgh. This is kinetic energy. Then kinetic energy equal 5 joules minus 4 joules. This is a kinetic energy. Kinetic energy equal 4 joules. Yeah, sorry. If you want, you can get final answer, make a fourth part answer by this method. Now it's don't need. Now it's 4 joules. All are correct, Fatima? Are you all correct? 4 joule. Kinetic energy 4 joule. Okay, get the velocity and final part. Okay, what is the velocity? What's the velocity? How to get the velocity? Now kinetic energy, now very easy. Kinetic energy 4 joules. No? Now fourth one, velocity, kinetic energy 4 joules equal half mv squared. No? Half mv squared. 4 joules equal half is a constant, mass 0.1 into v square. 4 joules equal 0.1 into 2 over 2, 0.05 into v square. V squared equal 4 over 4 divided by 0.05. It's very small value. V squared equal 4 over 0.05. What is this? 4 over 0.05. That means 500 over 5. The 400 over 5. 80, right? 80. 80. Now 80 square, 80 is the v squared. Now I need v, then velocity 80 square root 80. Very simple. 80 square root 80. 8.94. 8.94 meters per second. 8.94 ms minus 1. This is a velocity at a point 1 meter above from the ground level. Okay, now this is a fourth part answer. Final one, what is the answer? Final one? Final one? Actually, no need to calculate final one. If it is closed system, if there are no any additional factors affect on this object, let's calculate. Now a point or any point, C point or any point, A point total, A point total according to total mechanical energy conservation law, A point total mechanical energy equal to the final point. What is the final point? D point total mechanical energy. D point, because it throughout the path it is constant due to it's a closed system. D point total mechanical energy. Now A point total mechanical energy you got, it was 5 joules equal to D point total mechanical energy don't have potential energy, right? It's completely equal to the kinetic energy. It is half mv squared. No need to calculate it. It should be 10. If it is closed system, it should be 10, right? 5 joules equal 500 over 5. It is 100 equal v square. V equal 10 ms minus. Any doubt? You can ask now. Fatima? Sandit? Sadev? Okay. Okay, let's move into a tutorial questions. Tutorial question. Okay. No issue. That's today lesson. You have homeworks. You have homeworks. First question we discussed, right? Kabir, first question? No, not yet. No. First question not discussed. Okay, they are the homework. Question number 1. Please mark. Go to the final page of the tube. It is given here. First question. Second question. No, second question for now. Second question for now. Third question you don't need. Fourth question. Fifth question. Sixth question. Seventh question. Eighth question. Okay, they are the homework. You have a lot of homework today. Okay, the second question for now. Okay, second question. Please calculate and send. An experiment done by Galileo. Galileo is a scientist, no? A stone was dropped from the top of the 45-meter height tower. Find the velocity of this hit the ground. Okay, this is a question, very simple. Please note down this. An experiment done by Galileo. A stone was dropped from the top of 45-meter height tower. Find the velocity which is hit the ground. Okay, quickly write down the question as second example. Okay, we don't have time. We have only 10 minutes. Complete. Yumit? Okay, then you can draw a diagram. You can draw a diagram like this. This is the tower. It is 45-meter. This is the ground. It is 45-meter height from the ground level. This is a Galileo. Is a scientist. He fall a stone from this level to like this. Okay, what is the mass? The problem, the mass of the stone not given. We don't know how about the mass. How about the size of this stone? The question asks what is the speed or velocity fall down this stone on the ground. Alright, that's a task. I can give you 2 minutes. Think it is as a closed system, no any air resistance. Think as a closed system and get this answer. Habir, Sandit, quickly. Yes, very good. Others, you don't know the mass. Sadev, don't have time. Quickly. Fatima, I got. Yeah, what is the law? Mechanical energy conservation law. According to mechanical energy conservation law. According to mechanical energy conservation law. How to get this? How to get this? According to mechanical energy conservation law, the total mechanical energy at top of the tower equal to the total mechanical energy at the ground. Understood? That is a rule, no? That is a law. If it is a closed system, the total mechanical energy of each point, it is a constant. Now, total mechanical energy at top, it is only don't have speed, no? It is freely released. How about the initial point velocity? 0. Then it has only magnitude, mgh equal to total mechanical energy at ground level. Ground level mean, as I told earlier, don't have potential energy. Then it is only half mv squared kinetic energy. Half mv squared. Now it is same stone. Same stone means same mass. Then m to m cancel. G10. Height h. V squared. V squared we don't know. Sorry, half v squared. Half v squared. Half is a constant, v squared we don't know. Sorry, height is given, right? Height is 45 meter. 45 meter. Now cross multiplication, 415 to 2, 900. 900 equal v squared. V equal 30 meters per second. Who correct this? You mean do? We have that? I correct. Good. Okay. Now note down your homework. Note down your homework. Yeah, except third question. Third question එක ඕනේ. Third question එකෙත් only you can't do second part. First part you can try. First part you can do, not try. First part you can complete. Okay, that's all. Then you can, this is your homework. And next week I start power and efficiency, our final part of the lesson, and discuss these tutorial questions. And this is the end of next week is the final week of the month. No, this is the end of the work, energy, and power. Then 1st of February, first week of the February. First week means first, no? 1st of February, I'm going to start our 7th lesson. It is mechanical properties of matters, not cell structure. We're going to start mechanical properties of matters. Mechanical properties of matters. I'll share your, I'll post your tudes, mechanical properties of matters within this, within this next week. Tomorrow, starting week, I can post your tudes. Okay. Any doubt from today's lesson? Any unclear point? Any point? No. Then let's meet next Sunday morning with final part of the lesson. Goodbye.